Okay, so let's solve this Leetcode's problem number 2401, that is the longest nice subarray problem. So what does this problem statement have for us? You're given an array nums consisting of positive integers. We call a subarray of nums nice if the bitwise AND of every pair of elements that are in the different positions in your subarray is equal to 0. Return the length of the longest nice subarray. The subarray is a contiguous part of an array. Note that the subarrays of length 1 are always considered to be nice. So what they want is, they want you to make a subarray from the array that has been given to you, such that if you pick any two elements in your subarray, that bitwise AND has to be 0. For example, you see they've given an example of this array, of this array 1, 3, 8, 48 and 10, and they said that the output is 3. That means the longest subarray size is 3. That means you cannot add another element, because that would violate the condition of that element giving a bitwise AND equal to 0 with one or possibly more than one elements that are already existing in your subarray. So they claim that 3 and 8 bitwise AND is 0, 3 and 48 is 0, 8 and 48 is also 0, but you cannot add any other element, because that would violate the condition that the added element has a bitwise AND of not 0, not being equal to 0, with probably one or more than one elements in your array, in your subarray. So let's do a dry run and see what this wants us to do. So this is the example that they showed on the site. So first of all, we need to see what is the problem statement wanting us to do. So they want that if I have n1 and n2 in my subarray, if I want these two to be a part of my subarray, then what I want is take n1, take n2, but before including n2 and n1, I need to make sure that the bitwise AND of these two is equal to 0. Now what does bitwise AND mean? Say for instance you have an element, say the element is 0, which is n1, and you have another element, say n2, that is equal to 1. So doing a bitwise AND means, first of all, you represent this element in its binary representation. So what is its binary representation? It is 0 and 0. What is the binary representation of 1? That is 0 and 1. So doing an AND between these two is just simply multiplying individual bits modulo 2. What is 1 and 0? It's a false. So false is 0. 0 and 0, false and false is false. So if this result is all zeros, that means the bitwise AND is a 0. That means these two can be a part of your subarray. Now what would happen if I have, say, n1 equal to 1 and n2 equals to 3? Can I have these two as a part of my subarray? So first of all, we need to check what is the binary representation of 1. So this is 0 and 1. What is the binary representation of 3? That is 1 and 1. What do I need to check? I need to check the bitwise AND. So what is true and true? It's a true. What is true and false? It's a false. Now I see that the result, that is 0, 1 in binary, is in no way equal to 0, because you have a set bit. So this is the first intuition that we need to capture on. Why did this one come, first of all, in this place? Because there was a place in your two numbers which had a clash of ones. I mean, how would you get a true? You can only get a true if both of these are set bits, that is, this is true and this is true. That means whenever you try to add elements in your subarray, you need to check whether the bits that are set do not clash. Say for instance, you have a number whose binary representation is 1, 0, 0, and you have a number whose binary representation is 0, 1 and 0. Now if you want to check their AND, see, false and false is false, false and true is again false, true and false is again false. That means you get a bitwise AND of 0. So why did this all zeros come? Because there was no clash between the corresponding positions of the set bits. Here you see a 1, but here you do not see a 1. So false and true make a false. That means you cannot have two numbers in your subarray such that if you check any corresponding bit, the ith bit. So if the ith bit in your first number is a 1, then the only possible way that you can add the next element is the ith bit of your next number has to be a 0, because only then can you get this 1 and 0 as 0. Because if this was 1 and this turned out to be 1, you'll get a 1, and that is not allowed in your subarray. So that is the main intuition. You only add those elements which differ in the positioning of the set bits. Here you see a 1, okay, this place cannot be taken up by this next number. Here you see a 1, but this is allowed because this position is not a 1. Here you see both of them zeros, so both of them evaluate to false, that is being equal to 0. But how do you code this? It's a simple strategy. See, first of all, we need to see all the elements, so we need to traverse the entire array. So for that, we keep two markers. First is the yellow marker and the next is the green marker. So the green marker would let us traverse the entire array. And what would the yellow marker help us? This yellow marker would help us whenever there is a conflict or whenever there is a condition like this, that you are not being able to add a new element. So when you are not being able to add a new element, this yellow pointer would try to help you. I mean, how it will help, it will be clear subsequently, but for the moment just keep in mind that this yellow marker will turn out to be of your help. Now, at any point of time, I am interested in the number of ones that I have seen in a particular position. Okay, so let's say this has a 1 at this position. I know that for any number that wants to get added in your subarray, it cannot have a 1 at this place. The rest can be 1s. So this suggests that I need to maintain some kind of a mask that keeps tracks of the positioning of ones that I have seen previously. So for that, what I do, I create a mask. This mask is a dummy element of all zeros. So this is the number 0. So what is its binary representation of all zeros? That means every position is free to be taken up by the next element, whatever comes. So the next element that I see is a 1, that is above the green counter. So first question is, can I add this one into my existing subarray, which consists initially of nothing? So how do you check? You take the bitwise AND. So this is the bitwise representation of 0. What is the bitwise representation of 1? That is 0 and 1. Now you need to check the AND. What is the AND? False and true is false. False and false is false. That means it evaluates to 0. That means I can add this one in my subarray. How do you add? You just add to the mask mean you take an OR. This was my mask. Take the OR of my mask with the element that I want to add. That is just adding modulo 2. 0 plus 1 is 1. 0 plus 0 is 0 modulo 2. This adding tells me that there is an element whose set bit is 1 at this location. Now what this tells me is that the next element, if you want to add, cannot have a 1 at this place. So this mask and the updation of mask keeps track of the position of ones that I have already seen and already added in my subarray. So my new mask gets updated to being 0 and 1. So once I have updated my mask, I also need to maintain the longest or the size of the subarray that I have maintained. So what is the Subarray size, the subarray size, this is the maximum subarray. Maximum subarray size is 1 because this is the first element that I have added. Now let's check for the other element that are in my array. So who would let me check? This green pointer. I shift the green pointer one step ahead. So there you see, I have shifted my green pointer one step ahead. The mask has been changed to this after I have added a 1. Now let me check if I can add a 3. So I check by doing a bitwise AND. How do I check? I do a bitwise AND. So write the binary representation of 0 1 remains 0 because that is the original binary representation. What is the representation of 3? That is 1 and 1. Now check. Do you get all zeros? 1 and 1. There is a clash at this position. This one has already been taken up by some element that you have added. Now this 3 also comes saying that it has a 1 at this position. So when you do a multiplication modulo 2, what is 1 and 1? True and true evaluates to being true. That means this check does not pass. And what does it not pass? That n1 and n2 evaluate to being 0 because this is not 0. That means you cannot add a 3 because there is some element already existing in your subarray due to which 3 cannot be added because some element has already taken up this place and stored its 1 at this position. Now what to do? How do you resolve this conflict? You resolve this conflict by removing that element from your mask. But if there were more than say one element, you do not know due to what element this 3 could not be added. So what you do is sequentially remove one by one every element that occurs below the left pointer. See, why do we remove the element from the left position is due to this fact. Say you had this array and you had this subarray. You are checking and you want to check for this element, you want to add this element, but this says there is a conflict. The yellow pointer is say here. Now why not delete this? See, if you delete this, this chunk does not remain a subarray because you have deleted this place and now this place has a hole. So this is not a contiguous chunk. So that's why it's safe to remove the elements from the left and keep correcting and freeing up those places where you had a 1. So how do you remove? You subtract the element from the mask. How do you subtract? This was your mask. You subtract the element at the yellow counter. How do you subtract? You do a bitwise XOR or you just subtract modulo 2. What is 1 minus 1 is a 0. 0 minus 0 is a 0. Now you see the mask has been updated and there is one more position for the 1 to come. This 1 which was originally taking up this spot has freed its spot and now this spot has become empty for any other element that wants to come. So there is more independence for the next element to have a 1 in its binary representation. So now since you have removed an element, the mask becomes this. And since you have removed, you have not added any element, so the maximum size of your subarray still remains 1. Now you see, can you add 3 now? This is my mask, updated mask. Now can I add a 3? So I need to check the bitwise AND. So what is the AND? 1 and 1. So now if you check, this is all zeros. That means now 3 can be added. And what was the problem earlier? You had a 1 at this place. Now this position has become free, so this 1 can take this position. So now 3 can be added successfully. So add to the mask. How do you add? You take a bitwise OR. What is the OR? 1 plus 0 is 1, 1 plus 0 is 1. So this is my new updated mask and this is my new mask size or my subarray. Now let's see if I can add an 8. This is my mask. How do I check if I want to add 8 or not? I take the AND. So now you see there is no conflict at the 1 set bits. 1 and 0 gives you a 0, 1 and 0 gives you a 0, 0 and 1, 1 and 0. This is all zeros. So it all evaluates to being false. That means 8 can be added because there is no place where there is a conflict. So check has passed. Add to the mask. What is adding mean? It's just doing an OR. How do you do an OR? 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. So doing an OR is just addition modulo 2, and doing an AND. See, doing an AND is equivalent to multiplication mod 2. What does adding means? Adding is just addition modulo 2. What does subtracting means? Subtracting is just doing an XOR modulo 2. See, modulo 2 means the remainder. Modulo operation just gives you the remainder, what is left. So 1 plus 0 gives you a 1. 1 plus 0 gives you a 1. 0 plus 0 gives you a 0. 1 plus 0 gives you a 1. So this is my new updated mask. So now since I've added an element of 8, now my subarray size is 2 by 2, because 2 is the maximum of the current size and the previous size. So what is the maximum of 2 and 1? It's just 2. Now if I want to see, can I add 48? So just do that same check again. This is my updated mask after having added 8. I want to check if I can add 48 in my subarray. So I just write its binary representation. How do you do an AND? 1 and 0 is false, 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 because here you have a implicit 0. So the check has passed. That means you are safe to add 48. How do you add? Take an OR. Just add these two bits, these two representations. So that means you get this updated mask, and the maximum size also gets increased to being maximum of 2, and 2 was the previous size and 3 is the current size. So that is equal to 3. Now check for 10. Now we are getting the intuition. See, the mask has this representation. Now any element, in this case it is 10, if it wants to get added in my subarray, has to follow a certain property. That property is, if that element has a set bit at any of these locations, then you can't add. If the set bit is only at this position or at the positions indicated by these dots, then you can safely add, but not on these positions, because that would indicate a clash. So let's see for 10. So the binary for 10 is, now see, there is a clash. You have a clash at this location, at this location. That means you cannot add a 10, because the check does not pass of all being zeros. So now what do you have to do? You have to remove the yellow element. So what is the element at the yellow location? That is a 3. So what is the binary for 3? That is 1, 1. Now if you remove, just subtract. Now see, there are more places getting freed once you have removed the contribution of 3 from your mask. Now this is my new mask, and the maximum size remains 3 because you have just subtracted, not added. Now see, can you add a 10 after that removal of 3? Mask was this. Now try to add 10. Now can you add? No, because this position again has a clash. So the check does not pass. So what do? You remove the contribution of the yellow element. How do you remove? Just minus the contribution or take a bitwise OR. Now see, once you have removed the contribution, now this place is freed. So removing just makes the position free for the next element's set bit to come. So maximum size of the mask of the subarray still remains 3 because you've just deleted. Now see, can you add a 10? See, now there is no set bits that are clashing in any of the positions. That means you are safe to add a 10 in your subarray. The check has passed. So just add it to your mask. How do you add? To take an OR. So 0 plus 0. That gives you a 0. That gives you a 0. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. So this is your new mask. So what is the maximum subarray size? the maximum size earlier was 3. Now the maximum size is 2 because you only have these two elements in your mask. Okay, so what is the maximum subarray size? It is just 3. Just take the maximum. Now you end with traversing the entire array, and what do you return? You return 3 as your answer. So the steps are simple and clear. First you check. If the check passes, you add. How do you add? You take an OR. So there are 3 major operations in this entire algorithm. First you check the AND. If this passes, you take an OR. But if this fails, you take a bitwise XOR. XOR means subtracting, AND means multiplication, OR means an addition. So this is the entire thing that is happening in your subarray. So how do you code this? See. So what all things did we need for this problem to get solved? First was a yellow pointer that was at the start of your array. Then you had the maximum length of your subarray, which is initially 0 since you have not seen any element. Then you also store the size of your nums array. So these 3 things are initialized. Now you start your traversal. You start your traversal with the green element being at 0. Green has to be less than n, and just increment green. Now before adding you need to check, and you need to continuously keep checking until there is no more violation. So that means you need a while. Just initialize your mask also. So while mask and the nums of green does not pass the check, that means who would come to help you? The yellow. That means from your mask you have to remove nums of yellow, and once you have done that you have to increment yellow ahead. That means yellow plus plus. So after this while, you'd be sure that now there are no more violations. That means now it is safe to add the green element to your mask. So now mask becomes mask or nums of green. Now once you have added, you just check the maximum size. So that is the current maximum length, the maximum of your current length that you already have, and the total number of elements that are in your window. And what is that window? That window is this. From the yellow pointer to the green pointer, all the elements are added. So how many elements do you see in this picture? 3 elements. And how do you get a 3? Green minus yellow, a plus 1. So what do you do? Green minus yellow plus 1. These are the elements that are currently in your window that you are evaluating. So once you have done that, you have calculated the maximum length. Now you just return max length. So just run. That's correct, because the precedence was just to use the parenthesis because of this precedence, because it is getting evaluated first. So thank you.